Hello everyone, my name is Pengren Zou from University of Vigo. I'm pleased to attend this conference and met you here. My presentation title is Nutritional Potential and Fermentation Properties of Edible Heinsia crinite, guineense, and Xylopia aethiopica from Angola. This work was guided by Professor Paz. I introduce my research work from background, results, and discussion conclusion. There are three Angola medicinal plants. Their extractions show potential healthy benefits, such as antioxidant, anti-inflammatory, anti-malaria, women's health, and wound healing immunoprotective activity. In addition, they also have many other usages, such as spice for cooking, as well as preservative for inhibiting spoilage of foods. Until now, their special volatile aromatic compounds have been widely notified while the nutritional composition are not clear. Moreover, the bioactivity data of in vitro assay mainly characterized alkaloids and terpenoids, while few available information was about polyphenols. Plant polyphenol comprise flavonoids and bondphenolics. Typically, flavonoids are physically absorbed and retain visible matrix and can be easily obtained through organic solvent extraction. However, bondphenolics are covalently bound with dietary fiber through ester bonds, acid bonds, and carbon-carbon double bonds, making them difficult to extract. The important thing is that enzymatic hydrolysis and microbial fermentation not only promote the release of bondphenolics and change their component and activity of polyphenols, but also modify other bioactive compounds, thereby regulating their functional activity and bioavailability. Aspergillus oryza, a filamental fungus, is renowned for its famous high cellulose production, make it suitable for the fermentation of plant-based foods. For example, it can be directly fermented soybeans to produce beloved and popular products such as soy sauce, soy cheese, and soy pasta and nado. In addition, they can be used in combination with other microorganisms to ferment rice to produce Japan alcohol shake and China rice jiuliang and vinegar. Therefore, solid state fermentation with Aspergillus oryza represents a promising strategy, ensuring its growth on plant bacteria surface and as well as avoiding the detrimental effect of excessive water content on the substrates. This study research route involved treating these plants with complex enzyme treatment and solid state fermentation of Aspergillus oryza on these plants for different days, respectively. We aim to compare the effect of enzyme and fermentation on plants, polyphenols, other bioactive compounds, and functional activities, including antioxidant, antimicrobial. We attempt to elucidate action mechanism of solid-state fermentation of with Aspergillus oryza on these plants, with the goal of achieving high value utilization through this effective stage. Next, results and discussion. Regarding nutritional composition, crinite root contained abundant carbohydrate. Guineense seed has high yeast protein, while aethiopica pod was rich in lipid. It was observed that Aspergillus oryza grew slowly in aethiopica pod. Although despite adding 3 milliliters of 10 grams glucose solution to 2 grams subject. Therefore, carbohydrate content of plants mainly determines the fermentation degree of Aspergillus oryza, and the high lipid content of aethiopica pod is detrimental to ferment. According to amino acids profile, leucine was highest essential amino acids, and the aspartic acid and the glutamic acid were main non-essential amino acids. In order to evaluate nutritional value, the chemical score of essential amino acids was calculated by comparing with egg scoring pattern, and the results show that sulfur amino acids, methionine and cysteine were the main limiting essential amino acids in these plants. Although crinite root had no protein content, it was high in essential amino acids. As for fatty acids profile, palmitic acid and oleic acid, linoleic acid were main saturated, monounsaturated, and polyunsaturated fatty acids, while linoleic acid was only found in guineense seed. According to carbohydrate profile, glucose, albuminose, and xylose were major carbohydrate, and we find an appropriate amount of glucose is beneficial for fermentation. For mineral composition, all plants were particularly rich in calcium and potassium, iron and manganese were major micro mineral elements. Both enzyme and the fermentation significantly increased total phenolic content and the total flavonoid content, especially in crinite root. And as specialists, ELISA fermentation yielded superior results compared to complex enzyme treatment. Because as specialists, ELISA grew slowly on aethiopica pod, and the fermentation effect was inferior to other two plants. Both enzyme and the fermentation obviously raise the extraction concentration. In crinite root, complex enzyme treatment was better than fermentation, and increased guineense seed fermented 4 days was the best. For aethiopica pod, fermented 7 days was the best. As for DPPH antioxidant activity, fermented 4 days was the best on crinite root and guineense seed. However, in aethiopica pod, complex enzyme treatment was better than fermentation. For APTS, antioxidant activity, fermented 4 days was the best on these plants. As for FRAP antioxidant activity, fermented 4 days on crinite root and fermented 3 days on guineense seed, and complex enzyme treatment on aethiopica pod was the best, respectively. Quantification of major polyphenols in this plant by LC mass revealed that enzyme and fermentation increase their content. For some phenolics, complex enzyme yielded better results than fermentation, such as arginogenic and some polyhydroxide flavones. And for some flavonoids and the phenolics, solid state fermentation yielded better results than complex enzyme treatment, such as salicylic acid and vanillin procalcitic acid, fumaric acid, lutein, hemperferol, catechine, hemperferrite, ellagic acid, quercetin, hesperidin, and texiferin. Identification of volatile compounds in this plant by GC-Mass found that enzyme and fermentation altered their component and the relative content, with particularly marked changes in alcohol compounds and the terpenoids. And in addition, enzyme and the fermentation variously influence their quantity and composition, such as esters, aldehydes, and ketones and acids. For 2 grams negative bacteria, Escherichia coli and Salmonella tuberculosis, and 1 gram positive bacteria, Bacillus cereus, enzyme and fermentation did not significantly enhance their antimicrobial activity, but decreased it instead. Overall, enzyme and fermentation could slightly enhance their antimicrobial fermentation, with each treatment exhibiting a distinct advantage. Conclusion: Angola plants contain abundant essential nutrients, making them suitable for microbial fermentation to transfer bioactive components, and the solid state fermentation of asparagus oryza and enzyme hydrolysis treatment facilitate the release of polyphenols. Compared to enzyme treatment, fermentation more obviously improved antioxidant activities of this Angola medicinal plants. Fermentation treatment slightly enhanced antimicrobial capability of these plants. For our next experiment, we will investigate effects of microbial fermentation on other in vivo and in vitro biological activities of these Angola medicina plants and effects of different microbial species on the activity and the bioactivity of these Angola plants, and the biological safety and biological safety evaluation of microbial fermentation on these plants. I appreciate this project funding supporting my research work. For my research direction, metabolic transformation, modification, and the functional activity of dietary polyphenols, and the development of holistic delivery technology for functional food components. Thank you very much.